All right, hello there, y'all. Just going through this week, we are going to be covering probability. So, probability is what is the chance of some event happening? Okay, so like, what's the percent chance of it raining today? What's the percent chance of me winning the lottery? Stuff like that. So, probability is expressed as a fraction, a decimal, percent, or a ratio. We're going to be concentrating on fractions and decimals. Um, the first kind of problems that we're going to do right now are for single events. So that's like if you spin a spinner one time, or you draw one item from a box, or you take one card from a deck of cards, things that you're only doing one thing, okay? And the way that the probability for these events is expressed is the number of desired outcomes. So like let's say you're rolling a die, okay, that's one single die. Let's say that we want to know the probability of rolling an even number. Well, on a die, how many numbers are even? You've got 1, 2, 3, 4, 5, and 6 on that die. Well, 2, 4, and 6 are even. So there's 3 desirable outcomes. And then out of the total possible number of outcomes, well, how many numbers are on a die? 1, 2, 3, 4, 5, 6. So it'd be 3 out of 6, which then you would reduce that to 1/2. Okay, and we're going to get into this as we go through here. But just some things to remember whenever we're doing probability problems, okay? Coins have two sides, a heads and a tails. Okay, number cubes, they sometimes call things number cubes, they're dice. A standard one has 6 sides. Sometimes they'll tell you like a 10-sided die or 20-sided die or whatever, but if it just says a number cube, then know that they mean 6 sides. Okay, an even number means you can divide the number by 2. Okay, prime means that, well, let's go here. So even as you can divide it by 2, odd means you cannot divide it by 2. Okay, prime means that you can only divide the number by itself and 1. So for example, 5, 7, 11, 2, or 3, those are some of the first prime numbers. Okay, because you can't divide those except for by themselves and by 1. Consonants, they're all the letters in the alphabet except for the vowels, which are A, E, I, O, and U. So like B, C, D, those ones. Okay, so just any letters that are not A, E, I, O, and U, because A, E, I, O, and U are vowels. Okay, and then the last major thing is about cards. Okay, all of this is about a deck of cards. Okay, there's 52 cards in a deck. Half of them are red, half of them are black. So 26 are red, 26 are black. In the deck of cards, there are 4 suits. Okay, so you have hearts, clubs, diamonds, and spades. Okay, and so if you do 52 divided by 4, that means that there's 13 cards that are each a hearts, 13 clubs, 13 diamonds, 13 spades. And then within those things, there's 12 face cards total in the deck. Okay, you have Jack, Queen, and King. And again, there's 4 suits of those. So there's 3 of each kind. So there's like 3 face cards that are hearts. There are 3 face cards that are clubs. There are 3 face cards that are diamonds, 3 face cards that are spades. And so since there's the 4 suits and there's 3 of each, that means there's 12 face cards. So just kind of things to remember. Okay, you can also look up pictures of a deck of cards, and it shows you all the cards that are in the deck, so you can kind of get an idea there too. So those are just some kind of things to remember when we are talking about different items that are used in probability. Okay, so our first section that we're doing here, it's simple probability. This is just one event is happening. What's the probability of that one event? Okay, this is a spinner used in a board game. What is the probability that the spinner will land on a multiple of 9 and 6? Keyword here is and. So we have to look at these numbers here, and the numbers that are here, the ones that we want, have to be a multiple of both 9 and 6. So let's look at the first one here. Okay, 24. Well, 24, that's a multiple of 6, but can I multiply 9 by something to get 24? No. So I don't want 24. Okay. How about 64? Is it a multiple of 9? No. And how can I figure that out? Do 64 divide by 9. Okay. So in your calculator, just do 64 divided by 9, and you get 7.1 something. You see how it's just not an even, like, nice number? We got that decimal. That means it's not a good multiple, okay? It's not an even multiple of 9. So, and it's definitely not a multiple of 6, because if you do 64 divided by 6, you're going to get 10.6 repeating, so no good. Okay, how about 12? Is 12 a multiple of 6? Yeah. But is it a multiple of 9? No. That one doesn't work. Okay, 10. Is it a multiple of 9 or of 6? No. How about 18? Can we multiply 9 by something and then also multiply 6 by something to get 18? Yes. We could do 9 times 2 or 6 times 3. So 18 is good. How about 36? Well, 9 times 4 and then also 6 times 6. So is it a multiple of 9 and 6? Yes. 54? Okay, let's see. 54 divided by 9. Oh, it's 6. 9 times 6, that's 54. So that works for both of them. Okay, and then how about 22? Can I do 22 divided by 9 and get an even number? Nope. Can I do 22 divided by 6 and get a whole number here? Nope. So, not good there. So we can look at this. How many favorable outcomes do we have? 3. And then now of our total number of outcomes, we have to see how many spaces the spinner has in total. It's got 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's got 8 spaces. So 3 spaces have what we want out of a total of 8 spaces. So our answer is 3 out of 8 because you cannot reduce that anymore. So you're done. Okay, with probability, you got to make sure that you always reduce it. Okay, next one here. It says Lynn and Don tossed a coin 30 times and got heads 10 times. What is the experimental probability of tossing heads using Lynn and Don's results? Okay, now here the key word in this one is experimental. Okay, the theoretical probability, like what they should get, is 1/2 because a coin, well, one side is heads and the other side is tails, so you have a 50% chance, 1/2, of getting, heads. However, we have to go with their actual results here. So we're saying based on what they got, what's their probability of getting a heads from their results. So they tossed the coin 30 times, so that's our total number of outcomes, so that's 30. But they got heads 10 times, so that's the number of desired outcomes, so 10 out of 30. Now you can't leave your answer like this, you have to reduce it. And you can divide 10 and 30, you can divide them both by 10, so 10 divided by 10 is 1, okay? And then 30 divided by 10 is 3. So they have a 1 in 3 chance of getting heads on whatever coin that they are using. And if you want to know more about the difference between experimental and theoretical probability, then you should check out the video on the extension activity that we have. Okay, you have the numbers 1 through 25 written on slips of paper. If you choose one slip at random, what is the probability that you will select a number that is divisible by 5? Okay, divisible by 5 means that you can divide it by 5. So let's number this out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you don't have to number all this out whenever you're doing all these problems on the quiz. I'm just doing this so you can get a visual, okay? 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, so now we want to know what is the probability that we're going to get a number that is divisible by 5. So let's go through and see which of these numbers we can divide by 5. Okay, 1, 2, 3, and 4, I cannot divide those by 5. But 5, can I divide it by 5? Yes. Okay. What's another number that I can divide by 5? Oh, 10. Okay, what's another number that I can divide by 5? 15. And then 20. And then also 25. So I've gone through and I've circled all the numbers that I can divide by 5 and get a whole number, okay? So no decimals or anything like that. And there's 1, 2, 3, 4, 5. So there are 5 desirable outcomes. 5 numbers out of this list that I can divide by 5. Now I have to do this 5 out of how many? Well, how many numbers do we have written down, guys? 25. So 5 out of these 25 numbers are divisible by 5, but we have to reduce this. What can you divide both 5 and 25 by? Well, you can divide them both by 5. So 1, because 5 divided by 5 is 1, and 25 divided by 5 is 5. So the probability is 1/5. And with these fractions, guys, if you download that TI sample software that I put on the activities page, that will help you to reduce these fractions. Also, if you just Google, there's a fraction calculator out there somewhere, and it'll reduce the fractions for you as well. Okay, and if not, you can always turn all the answer choices into decimals and compare it that way. Okay. A drug trial is testing the effectiveness of 2 drugs. If 20 patients are given drug A, 60 patients are given drug B, and 90 patients are given a placebo, what is the probability that a patient will not be given a placebo? Okay, placebo, guys, is a sugar pill. Okay, so when they're doing tests and stuff, they give certain people the actual medicine, and then they give other people a sugar pill, and that's what the placebo is. So the sugar pill doesn't do anything for you. So in case you don't know what placebo means. So look at this here. What is the probability that a patient will not be given a placebo? Keyword here, not. So the desired outcomes here are the people who are getting the actual medicines, not the people who are getting the placebo. So whenever you see that word not, you want to go, like, see how it says not and then placebo? We want to go with everybody else except for the placebo people. Okay, so that's kind of how that word not means. So it says there's 20 patients who are given drug A and 60 patients who are given drug B. So are not placebo people. It's 20 plus a 60. So that's 80. So 80 people are not getting a placebo, but then we have to have the total number of people. So we have to add up all 3 groups, the 60 and the 20 and the 90. And when you add that, you get 170. So 80 out of the 170 people are not getting a placebo. And then we just have to reduce this. They both end in 0, so we can divide them both by 10. So it's going to be 8 out of 17. And 8 and 17, you cannot divide that further. So you have an 8 out of 17 chance of not getting the placebo. Okay, another way that you could approach this problem is you could see here all the probabilities. If you're in this study, you will get some kind of a pill. So that's 100% probability there. Okay, so all 3 probabilities, the probability that you get drug A, the probability that you get drug B, the probability that you get a placebo, all 3 of those have to add up to 1. Okay, so now what we can do here, and this is just a different way to get the same result. Okay, so if you don't want to hear this alternate method, just skip on to the next problem. So we'll have we can find out the percentage of people who are going to get the placebo, so 90 out of 170, okay? So that would be 9 out of 17. And then to figure out the percentage, so that's, this 9 out of 17 is the people who are getting the placebo, okay? And so to find the people who are not, well, we would take the 17 out of 17, because that's the 170 people out of the 170 people. Take away the people who are getting the placebo, and that will tell us the people who are not getting the placebo. So if you want an alternate manner, okay, you find the percentage, whenever they're giving you a not problem, you find the percentage of the people that are actually getting something, and then you subtract that from the total, and that will give you the part that's not, okay? Because the 9 is the people who are, the 8 is the people who aren't, and then the 17 is the total of people, okay? So just a little extra probability stuff there. Not trying to get into too much detail, but if you like it. Okay, number 5 here. It says Lenny's favorite radio station has this hourly schedule. News is for 20 minutes, commercials is 1 minute, music is 39 minutes. If Lenny chooses a time of day at random to turn on the radio to his favorite station, what is the probability that he will hear the news? Okay, so news is what we're interested in. So the news is 20 minutes. Okay, out of, now it says hour, but you know, let's add up all the three types of things that are on the radio station. So we have 20 minutes for news, 1 minute for commercials. That's a good station. And then 39 minutes for music. Okay, add that all up. Well, how many minutes is it? It's 60, which is 1 hour. So 20 minutes out of every 60 minutes is news. So let's reduce that. Well, 20 and 60, you can divide those both by 10, so 2 out of 6. But 2 and 6, you can divide those both by 2. So 2 divided by 2 is 1, and 6 divided by 2 is 3. So he has a 1 in 3 chance of hearing the news when he goes to his favorite radio station. Okay. So now, number 6 here, it says you have the numbers 1 through 24 written on slips of paper. If you choose one slip at random, what is the probability that you will not select a number divisible by 5? Okay, let's number this out again. And again, I'm doing this for the visual so you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, we want to see the numbers that are not, or that are divisible by 5. Okay, so the numbers that are divisible by 5. Well, we have 5, 10, 15, and then 20. Okay, so look at this. We have 1, 2, 3, 4. We have 4 numbers out of a total of 24 numbers that are divisible by 5. So that is, and 4 out of 24, that's 1 out of 6. 4 divided by 4 is 1, 24 divided by 4 is 6. Okay, so these are divisible by 5. Okay, so 1/6 of the numbers are divisible by 5. But what do we want? The ones that are not divisible by 5. Okay, y'all look. 1 out of 6, they actually are. So that would mean that 5 out of 6 are not divisible by 5. Okay, and let's actually look at this. I'm going to count the ones that are not circled. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have 20 out of 24. Okay, guys, 20 out of 24. Think about it. 20 and 24, what can you divide them both by? 4. 20 divided by 4 is 5. 24 divided by 4 is 6. So 5, 6 are not divisible. Okay, but do y'all see how 1/6 plus 5/6 equals 6 out of 6? So the two, what I was trying to communicate to y'all up here at number 4 is that the part that is and the part that is not, they have to add up to one whole. Okay, so kind of think about that as you're doing these problems. All right, the two-way frequency table shows the results of a survey of middle school students. Find the probability that a randomly chosen student is a male who enjoys reading. Okay, so a male who enjoys reading, and it's a randomly chosen student. So we're going to be comparing the males who enjoy reading to the total number of students. So this problem is more just kind of showing you how to read this chart. So first thing, we need male, and then the other direction we have here is enjoyment of reading. So males that enjoy reading, well, there are 15 of them. And then now we need to compare this select group of people to the total number of people. So it's the total students, okay? Total students. So 15 out of 85 students are both male who enjoy reading. And so now you see here it says round to the nearest thousandth. So that means 3 decimal places. So just type 15 and divide it by 85 in your calculator. And you get 0.1764. Okay, and the thousandths is the third decimal place here, so we have to look at this one. So the 4 is not going to make that 6 go up, so it's 0.176. Okay, and this is our last problem here for simple probability. We're going to get into some other ones here in just a second. A spinner is numbered from 1 through 10, with each number equally likely to occur. What is the probability of obtaining a number less than 3 or greater than 8? Okay, so let's just set this up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this word or here, all right, that means that you have to add together the two things, the two conditions that you're looking for. So less than 3, well, how many numbers are less than 3? 1, 2. Or greater than 8, well, 9 and 10. So I have 2 numbers that fit the first condition and 2 numbers that fit the second condition. I have to add those together. 2 plus 2 is 4. So I have 4 desired outcomes out of, and then how many outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10. 4 tenths. But we can't leave it as that. We have to reduce it. You can divide both of those by 2, and you will get 2 fifths. So you have a 2/5 chance of getting a number that meets either the condition of being less than 3 or greater than 8. So I want you to keep in mind that word or, you're going to be adding. Okay? Or goes with adding. So just keep that in mind. All right. So next thing that we have, this next section, we've got independent versus dependent events and compound probability, conditional probability, and then using and or. Okay. So independent versus dependent. Okay. This is when we have more than one event happening. Okay, so like this would be if you take 2 cards from a deck of cards. Okay, and that it'll be independent if you actually return the cards to the deck, but it would be dependent if you didn't return cards to the deck. Okay, so independent, just going to abbreviate it, one event does not affect the other. I think it's effect. I always get this confused. Maybe y'all can tell me how to separate them more effectively. Okay, one event does not affect the other. Okay, so an example would be drawing cards with replacement. So like I said, if I took one card out and I looked at it and then I put it back in the deck and then I drew another card, those would be independent events because me taking the one card out and then putting it back doesn't affect the probability for the next card to be drawn. Okay? Or for example, if I take something out of one container, like I have two containers, right? The probability of me drawing one thing from the first container is not affected by the other container because they're not together. Okay, they're like separated. Okay, dependent. One event does have an outcome. Okay, so for example, if I'm drawing cards from a deck, but I don't put them back. Okay, so for example, right now, let's say I'm going to talk about drawing a red card, okay? Red cards in a deck. There's 26 out of the 52. So now I draw one, okay, and let's say I drew a red card. Well, if I drew a red card, think about what that does to these two numbers. If I draw a red card on my first time, well, now instead of 26 red cards in the deck, there's only 25. And then think about the total. If I don't put that card back in there, well, there were 52 cards, but now since I took one out, there's only 51. So do you see the probability of getting a red card went from 26 out of 52 to now being 25 out of 51. And those are different numbers. Okay? So dependent is when one event affects the next one. Okay? So that's independent versus dependent. So let's go look at these first examples here. So it says, at the pet store, you choose a bird from one cage. It is a male finch. You also choose another bird from a separate cage. It is a female finch. Okay, and we're assuming that these birds are chosen at random. Okay, you're not trying to choose a male and a female. Does choosing one bird from one cage have any effect on the bird that you're choosing from the other cage? No. Okay, the two cages are completely separate, so these would be independent events. One cage does not have effect on the other. Okay, you flip a coin 3 times. You get a heads, and then a tails. Determine whether the scenario involves independent or dependent events. Okay, y'all. Just because I flip a coin once, does that make the coin decide to get a different result the next time? No. Okay? Flipping a coin, the previous flips have no effect on any further flips. So that would be an example of an independent event. Okay? There are 6 blue socks and 4 green socks in your drawer. You randomly pick a sock out of your drawer and place it on a counter. Okay? Place it on a counter. All right, guys, think about this. You are taking a sock out of there, so you're changing the makeup of the socks in your drawer. You have changed the group that you are picking from. So it says, and it says both socks are green. So let's just focus on the green socks. So there's 6 blue socks and 4 green socks. Okay, so originally you had 4 socks that were green out of a total of 10 socks. You took out 1 green sock. And you didn't put it back. Well, now think about it. Green, how many green socks do you have? You no longer have 4 in there. You only have 3. This is in the drawer, okay? And then now the total number of socks. There were 10, but you took 1 out, so now it is 9. So your probability of getting a green sock went from 4 out of 10 to being 3 out of 9. Very different numbers. So taking that sock out without putting it back in, that is the cause of a dependent event. It changes the probability of the next one. Okay, next thing we have here is compound probability, conditional probability, and then the and or. Okay, it's when you have 2 or more events, okay? 2 or more events. If you have dependent events, then you're dealing with conditional probability there, okay? And then when you have and, you see the word and, you're going to typically multiply the probabilities. And then when you see that word or, you're going to typically add the probabilities. Okay, and then you're going to subtract outcomes that are double counted. And I'll show you an example of that. Okay, so you're going to subtract outcomes that are double counted. And this is when you see the word or. Okay, and with these ones, it's just kind of best just to do some examples. So it says you flip a coin and then you roll a fair 6-sided die. What is the probability that the coin lands tails up and the die shows an odd number? Okay, so we have 2 events. They are independent. The coin flip does not affect the roll of the die, but what we do with these 2 things is we multiply their probabilities together. So for the coin, okay, for getting a tails, it's 1 out of 2, okay, because there's 1 side that's tails out of the 2 sides of the coin. For the die, well, there are 3 odd numbers out of a total of 6 numbers on that cube. And then 3 out of 6, that also reduces to 1/2. Okay, to find the probability, we do 1/2 times 1/2. And so 1 times 1 is 1. And then you multiply the bottom numbers. 2 times 2 is 4. So the probability of getting a tails and also an odd number is 1 out of 4. Okay, and you can actually make like a chart that shows all the different outcomes for this, and that will show you why you multiply here. But just when you have the 2 events, okay, you see the word and, you're going to be multiplying. All right, your sock drawer has 4 white socks, 2 brown socks, and 2 black socks. You randomly pick 2 socks without replacement, keyword, without replacement, so that makes this a dependent event. What is the probability of pulling 2 brown socks. Okay, so this is basically the probability of brown and brown. So the reason why I wrote it like this is because that word and, okay, and means you're going to be multiplying. So first look at the probability of getting just one brown sock from the initial group. Okay, we have 4 white socks, 2 brown socks, and 2 black socks. So 2 brown out of a total of 4, 5, 6, 7, 8. Okay, 2 out of 8 is the initial one. Now we have to say, okay, we took out a brown sock. We're not going to put it back. So that means that now instead of 2 brown socks in the drawer, we only have 1 brown sock. And now instead of 8 socks in the drawer, we only have 7. And so we multiply. 2 times 1 is 2. 8 times 7 is 56. Now both of these numbers here are even, so we can divide them by 2. So divide 2 by 2, you get 1. Divide 56 by 2, you get 28. So you have a 1 in 28 chance of pulling out 2 brown socks. So that would mean that if you did this experiment 28 times, you would get 2 brown socks 1 out of 28 total times of doing this whole taking 2 socks out. All right. And so again, you see where it says like the probability of pulling 2 brown socks. You have to think to yourself, okay, I'm going to pull one and then I'm going to pull the other. That and comes into play there. Suppose you choose a marble from a bag containing 3 red marbles, 3 white marbles, and 5 blue marbles. You return the first marble to the bag and then choose again. Okay, find the probability of red and blue. Okay, that P with the parentheses here, find the probability of red and blue. That's how you read it. So first, probability of red. So how many red are there? So we want red out of the total. So there's 3 red, and then add it up. 3 plus 3 is 6, plus 5, there's 11. Okay, there's 3 out of 11. Now it says we return it. Okay, we return it. So now we're going to choose again, but this time we went blue. Well, how many blue are there? There are 5 blue out of a total of 11. Okay, our total didn't change because we returned that first marble. So to find the probability of red and blue, we multiply. So 3 out of 11 times 5 out of 11. Okay, 3 times 5 is 15. 11 times 11 is 121. And here we can't reduce it, so this is as simple as it gets. Okay, number 15. It says you have 5 $1 bills, 4 $5 bills, and 2 $10 bills in your wallet. You select a bill at random without replacing, okay, without replacing. Then you choose a second bill at random. Find the probability of a 10, then a 1. So this word then is like the word and, okay? So first thing, what's the probability of getting a $10 bill? Well, we have 2. So you have 2 out of, and then now you have to look at the total kind of bills here. We have 5, 1, so 5 plus 4, 5. So 5 plus 4 is 9, plus 2, okay, that's 11. So 2 bills out of our 11 bills are worth $10. And now, since we have and, we're going to multiply. Now think about it. We took 1 bill out. We had 11 of them in our wallet. But now, since we took 1 out, we only have 10. But what are we looking for this time? A $1 bill. Well, how many $1 bills do we have? We have 5 of them. And we didn't take one of those out before, so we still have our 5. So now we just multiply this. 2 times 5 is 10. 11 times 10 is 110. Okay, and now we can reduce these. They're both divisible by 10. So it's 1 out of 11. So you have a 1 out of 11 chance of pulling out a 10 and then a 1. All right, last few here, guys. Okay, a pet store has 2 tanks of tropical fish. The first tank contains 4 bluefish and 6 yellowfish. And then the second tank contains 6 bluefish and 7 yellow. If Keisha randomly purchases a fish from each tank, what is the probability that both fish will be blue? Okay, so we have to do the probability of getting a blue from the first one multiplied by the probability of getting a blue from the other one. And they're separate tanks, so they're independent from each other. So the first one, okay, we have 4 blue, but then we have to look at the total. There's 4 blue and 6 yellow, so 4 plus 6. There's 10 total in that first tank. Times, because we want 2 fish, right? And this one is 6 blue fish. Okay. And 7 yellow fish. So we have 6 out of, and 6 plus 7 is 13. So we have a 6 out of 13 chance of getting blue from the other one. Since we want both of them, we're going to multiply. So 4 times 6 is 24. And then 10 times 13 is 130. Okay, now I can see both of these numbers, they're even, so I'm going to try and just divide by 2. So 24 divided by 2 is 12. And 130 divided by 2 is 65. Okay, there's no other factors here that we can divide by, so that's our simplest answer. 12 out of 65. Okay, next. And this is an interesting one. A jar contains 6 blue cubes, 3 blue spheres, okay, 3 green cubes, and 6 green spheres. Okay, so be careful. There's colors and shapes on this one. It says, if you select an object at random, what is the probability that the object is green or a cube? Okay, so be careful. So what is the probability that the object is green? Okay, remember that word or means we're going to be adding here. So green. How many of these things are green? We have 3 green cubes and 6 green spheres. So we have 3 plus 6, so that's 9. Okay, and this is the green. So this is 9 things that are green out of, and then how many total things are here? Well, 6 plus 3 is 9. Then we have over here 6 plus 3, that's also 9. So 9 plus 9, there's 18 total things in this bag. Okay, or the jar. So 9 out of 18 are green. Now let's talk about cubes, because that's the other condition. Well, how many of these things are cubes? Okay, we have 6 cubes that are blue and 3 cubes that are green. So again, 6 plus 3, that's 9. And this is cubes. So we have 9 out of a total of 18 objects that are cubes. So you might say, okay, 9 out of 18 plus 9 out of 18, that's 18 out of 18. Well, here's the thing though. We've actually double counted something. Do you see how it says green or a cube? In figuring out the green items and figuring out the cubes, we've actually double counted the green cubes, because the green cubes are counted over here in the green items, and they're also counted over here in the cubes. So we have to see here, okay, we have 9 out of 18 for green, plus 9 out of 18 for the cubes. But now we have to subtract out those items that are double counted. So how many items meet both conditions? Well, 3. There's 3 out of the 18 that are green cubes. So 9 plus 9 is 18, okay? But minus 3, that's 15 out of the 18. And then you can divide both of those by 3, so it's 5 out of 6. So you have a 5/6 chance of getting an item that is either green or a cube. So just whenever you have these OR problems, you just have to make sure that you subtract out anything that gets double counted. So the green cube here, that was the key thing. It was counted under green. It was also counted under cubes. So make sure you subtract anything that gets double counted out. Okay, last 2 problems here. These ones are here because they are conditional. Okay, so number 18. It says Thomas, Jenna, and Maria are playing a game. They have a bag that contains 34 white tiles and 2 red tiles. Okay, 2 red tiles. Each player takes turns picking a tile at random and does not return the tile to the bag. The player who draws a red tile first is the winner. In the first round, Thomas goes first, then Jenna, then Maria. And none of them draws a red tile. Okay, so key thing, nobody drew a red tile. What is the probability that Thomas will win the game on his second turn? Okay, so to win the game, we have to get a red tile. So we have to look at what is the probability of getting a red tile after, key thing is after, because this is our condition, 3 white tiles have been drawn. Okay, because you have to look at it. It says they all went in the first round and nobody won. Well, how do you win? By getting a red tile. So if you draw out a white tile, then you lose, right? So what's the probability of getting a red tile after 3 white tiles have already been drawn? So the first round, there were 2 red tiles out of, you have to be careful here, total. Okay, there were 34 white and 2 red. So what's 34 plus 2? 36. Okay, that's the first round. But then they each drew 3 tiles. And they're all white tiles, so it doesn't affect the red. So now this is the second round. And Thomas is going to go first. Well, there's still 2 red tiles, but they've drawn out 3. So you have to do 36 minus 3. So it's going to be 33. So he has a 2 out of 33 chance of drawing a red tile in this round. Okay, so this is conditional probability because the probability of this event here is conditional upon what happened in this first round. Okay, because we had some tiles and then we took some out, so it changes our probability. So this might look like it's 2 separate events that you need to multiply the probabilities here, but it's not truly. Okay, you just have to think, okay, we took out 3 tiles. Well, what's the probability of having the red tile now out of how many total tiles there still are? So just kind of watch out for problems like that. Okay, next one, and our last one. So it says, if all possible results are equally likely, what is the probability that a spin of the spinner will land on a lowercase letter or a consonant. Okay, so a lowercase letter or a consonant. So first thing I'm going to do is the lowercase. Okay, so that means not a capital letter, okay? A lowercase letter. Well, we have 1, 2, 3, 4, 5. We have 5 letters that are lowercase out of 5, 6, 7, 8, 9, 10. Out of 10, okay? So lowercase letters, 5 out of 10. Now, consonant. How many of these letters on this spinner are consonants? Well, J is a consonant, H is a consonant, G, F, D, C, and B. Okay, 1, 2, 3, 4, 5, 6, 7. So 7 out of the 10 are consonants. But now we have our special group. We have to make sure that we don't double count. Consonant and lowercase. How many fit that? How many lowercase letters are also consonants? 1, 2, 3, 4. So 4 out of the 10. So find the probability of getting either a lowercase letter or a consonant. We have to add the two separate categories and then subtract where they overlap. So 5 plus 7 is 12, minus 4, you get 8. And then the tens, it just stays the same. That's your rules for adding fraction. So 8 out of 10, and you can see here for the answer, we want it as a decimal, so it's 0.8. So there you go. Okay, guys, now this was just a really, really rough introduction to probability. It definitely does not cover everything and it does not go into depth, but I tried to really kind of look at the quiz that we're giving you guys and mirror it after that. So if you're going, I've made some practice problems. If you're going through those and you have some questions, please email your teacher. Let us know. We'll be able to help you guys out. And I look forward to seeing you guys later in the fall, most probably. All right. Well, y'all have a good time. See you later.